Hi, my name is Sridhar and today I'm talking about Turing machine and the basic idea behind Turing machines. Turing machines are powerful devices with an interesting property. They are not physical devices but rather abstract mathematical objects. They were developed by Alan Turing in 1936 while he was working on the Einstein's problem or decision problem. The decision problem is a fundamental to logic. After having been around for some time, the problem was formalized by David Hilbert in 1928. The decision problem is concerned with the validity of propositions. It rains when it's raining is true, for example, and it rains when it's not raining is false. Specifically, Turing was interested in the question, what is computable? The machine developed by Turing can mathematically describe any operations any modern computer can perform just by following a few simple rules. In fact, it is capable of describing infinitely many operations, though not very conceivable operations is possible on a Turing machine. Turing machines find applications in mathematics and computer science as powerful yet simple explanatory tools. Let's look at the basic parts of a Turing machine. One of the key components is a strip of tape called the tape or memory. The tape is infinite in length and is divided into an infinite number of cells. Each cell holds a character or symbol which can be read or overwritten by the machine's read-write head. The alphabet of characters that can be represented on the tape is given the name sigma. Our example machine in this lesson will use the characters 0 and 1. Then 0 and 1 then are characters that are allowed to be written on tape. There is another alphabet Turing machine use which we call tape alphabet and represent with gamma. It contains 0 and 1 from sigma as well as a few special symbols used in computations. These symbols mark the start position, the end position, and a blank or unused cell. The portion of the tape enclosed by the start and end symbols make up the input. The read-write head is always positioned over exactly one cell and can read a symbol from that cell or write a new symbol in its place. The machine has the ability to move the tape one cell to the left or to the right anytime during operation in order to reposition the read-write head. It may also elect not to move at all during an operation. With this setup, the tape acts as both an input-output device and a storage medium for information. The way Turing machine uses this structure, the input is well written on the tape. The machine starts by reading the first symbol and writes a new symbol in its place according to a set of instructions. The instructions also tell the machine which direction to move. The machine follows this read-write-move cycle over and over again until it is told to halt. The string written on the tape at the end of all of this is the output and the computation is complete. Turing machines are useful for several reasons. They give us the first theoretical model for building actual computers. Though computers no longer use this model, instead preferring electrical and a few mechanical components, Turing machines are still used widely in computer science as models for computation. Algorithms for solving problems can be expressed in Turing machine languages, and languages can even help with understanding how programming works. With the mathematical machine designed, a simple but important definition arises regarding computability. A number of function is said to be Turing computable if there is a Turing machine that can compute it. That means that Turing machine can tell us a lot of computation in general. In addition to being easy to build and manipulate mathematically, we can learn about the limits of computation using Turing machine in this way.